This set of data we found yesterday, the 5-number summary, right? 5-number summary are 5 things. Minimum, smallest number. Maximum, biggest number. Median, middle number. Q1, what is Q1? There you go, the median of the lower half, right? Everything below the median. Q3 is the opposite, the median of the upper half, right? Everything past the median. That's where we stop. Okay. All right. So now, so we had those. So now what we got to do is actually build the box plot. Okay. So actually build the box plot. Once you have these numbers, box plot's not too bad. Okay. So a box plot is like a dot plot. It needs a number line. Okay. So we need a number line first. Okay. So let's draw a number line. Okay. It needs to have every single one of these numbers on the number line. So the smallest number is 44. So it has to have 44 on it, and it has to have 80 and everything in between. So you can label by 10s, by 5s, by 1s, by 2s, whatever you want, as long as it's the same, consistent. Okay. So we could start with 40 and go by 10s. 40, 50, 60, 70, 80. You can go by 5s if you want. It just depends on what you. Okay. The first thing, we always start with the middle, the box, the median. Okay. So the first thing we're going to do is I'm going to make a line. I'm going to make a line where the median is. The median is 65.5. So right about there, I'm going to make a line that looks like that. Just a straight line like that. That's the middle of the box. Okay. Then I'm going to go to Q1 and Q3. Q1 is 61.5, which is right about there. Q3 is a little over 71, 71.5. Close that part. That's the box. They call it a box plot because there's a box. Okay. Now the last part is you make a little line for the minimum. So the minimum is 44. The maximum is 80. And then you draw a little line that extends to there. Okay. And there's the box plot. Okay. Now box plot there's more to it than that. For example, so we'll go over it. 25% of the data is in here. 25%, I want to use a different color. Okay, so 25% of the data is in here. So that goes from what, 44 to 61.5. So go back, how many numbers? How many of these numbers were from 44 to 61.5? How many? Like, how many fit into that category? Well, let's see. Let's see here. 1, 2, 3, 4, 5, 6. 6 of the numbers fit into that category, right? These 6 would be somewhere in here, right? How many are there total? How many numbers are there total? 24, right? 6 out of 24 is a quarter, okay? So let's go to the next one. I'm gonna use a different color. Right here, this part right here. 25% of the data are in that. That goes from 61.5 to 65.5. How many numbers do you think are from 61.5 to 65.5? Yeah, 1, 2, 3, 4, 5, 6. Okay, it's all the same. They're all the same percentage. Okay, they're all 25%. I could do that for this guy here, and I could do that for this guy here. Okay, so let me ask you a question. The blue extends wider than the pink, right? The blue is a little wider than the width of the pink. Why is that? If they're both 25%, shouldn't they all be the same length? Why is the blue here a little bit wider than the pink here? Why is that? What's causing that? Not the outlier. So in other words, like this. This is this width, right? The blue is that width. The pink is only this width. Less than half, right? Why is that width? Why is this width a lot smaller than this width over here? Yeah, exactly. The gaps between the numbers. From here to here, the spread goes from 44 to 61. That's 17. But from here, the range in here is only from 62 to 65. They're really close together. 62 and 65 are really close. But 44 and 61 are pretty far away. Okay? So that's what causes the differences. Okay? If numbers are really clumped together, 25% were from 62 to 65. Another 25% were from 65 and a half to 71 and a half. Right? And then another 25 were from 71.5 to 80. Okay? So if numbers are closer together, bunched together, that's spread. Okay? That's what causes the lengths to be different. Okay? Let's see, anything else? So we talked about, so the other thing, so we've talked about shape, right? We've talked about shape, we've talked about center, mean. We use the mean when symmetric. We use the median when it's skewed at all, when it's skewed, right? Because the mean always wants to go to the extreme values, right? And the only time those balance out is when it's symmetric. Okay, that's what we talked about yesterday. Next week, we're going to talk about spread. That's the last thing we're going to talk about, spread. Today, what we're going to talk about is outliers. Outliers. In your best definition, you guys have all heard of outliers. What's an outlier? Your best definition. I'm not looking for like perfect textbook, but what's an outlier? Yeah. You're Sean. Okay, numbers can skew the data. Why though, Jordan? Extremely different, right? So numbers that are extremely different. So if I wanted to look at numbers that were extremely different from this, where would they be? Yes, yeah. A lot bigger or a lot smaller, right? Even smaller than 44, even taller than 80, right? Those are outliers, right? Okay. Well, the question I always get is how big? Like, how tall do you have to be in this class to be considered an outlier? Would you consider 80 an outlier? Is that person an outlier? 44, would you consider that an outlier? Some people would say yes, some people would say no. So where's the answer? It's right here. It's right here on the board. Okay? To be too tall, you have to be taller. Let me write it up here. So you have to be taller. Or I should put height. I shouldn't put taller. Bad grammar. Height has to be greater than Q3 plus 1.5 times the IQR. Okay. Do we know what Q3 is? Yeah, we just did it, right? IQR, that's the new one. We haven't talked about IQR. We'll talk about it right now. IQR is this. It's the distance from one edge of the box to the other. Right there. How far is it from here, this side of the box, to this side of the box? How far would I need to travel? In other words, yeah, Krishan. In other words, yeah. In other words, what I'm saying is we call it IQR. It's called interquartile range. That's the formal name, but we call it IQR for short. So IQR is Q3 minus Q1, right? Q3 is one edge of the box. Q1 is another edge of the box. You subtract them and you get IQR. Okay, so in this case, Q3 was 71.5. Q1 was 61.5. You subtract them and you get, what do you get? 10. So IQR is 10. Okay, so now we know what that is. So let's plug it in. Let's plug it in to see what's too tall. Q3. Q3 is 71.5 plus 1.5 times the IQR, which we just found out was 10, right? Okay, so crunch the numbers, multiply and add. What do we get, 80 something? 86.5. That means in this class, to be considered an outlier, you have to be taller than 86.5 inches. Is anybody in this class taller than 86.5? No. So even if you think someone is tall for that class, they're not. They have to be 86.5. That's pretty tall. That's like 7 feet. That's over 7 feet, right? So to stand out, to be an outlier from this class here, you had to be that tall. So is there anyone too tall? No. Okay, how about too short? We said 44, right? That person that was 44, that might be too small, too short. So let's see. We're going to do the same thing. So this one is very similar, just uses a couple different things. So height has to be less than Q1 minus the same number, minus 1.5 times the IQR. Okay. So we're subtracting instead of adding, and we're using Q1 instead of Q3. All right. So Q1 is 61.5 minus 1.5 times 10 again. It's the same IQR because it's the same set of data. So 61 minus 15 is, what do you get? 46.5? We have an outlier on the short side. So 44 is an outlier. So 44 would be an outlier. So are there outliers? Yes, 44 inches. So the really tall person, not tall enough. The really short person, short enough. Okay, that's how you tell. That's how you can tell. That's how you use. So if they want to know if something's an outlier, that's what you got to use. Either the too big outlier formula or the too small outlier formula. Okay, depending on what you want to check. Is it too big or is it too small? Okay. All right. Okay. Oh, one thing before we go on. Another thing you're going to see, it's not on here, but I want to add it to here because you're going to see it. It's called a modified box plot. A modified box plot. because you're going to see this a lot. A modified box plot is the same thing as what we just did. Okay, so let me redraw this. $40, $50, $60, $70, and $80. The only difference is we use a star to show any outliers. We use a little asterisk, a little star to show any outliers. Okay, so for the ones we just did, didn't we have an outlier? 44, right? So over here, we put a star at 44. So 44 would be right here. Because I use this formula here. Because I used the formula, I plugged it in, and that's the number I got. I got 46.5. Anything lower than 46.5 is considered an outlier. Okay, so yeah, just use the formula. It'll always be that formula. This is the formula you'll always use. It might not be height. Like on the next one you guys are going to do, we don't talk about heights. I think it's home runs. This one here is talk about heights. So is heights less than Q1 minus 1.5 the IQR? Okay. Yeah, that's why I say it's a too big outlier, because if it's too big means it's an outlier. It's greater than whatever number I come up with here. Too small, greater than the number I come up with there. Okay. All right. Okay, so let's go back real quick. So I got a star there. Everything else stays the same except for the star. Okay, so the median is still 65.5. Q1 is still 61.5. Q3 is still 71.5. That's still the box. 80 is still out to here. Okay. But we don't extend. The star doesn't touch the graph. So I can't extend. You know how I extended all the way over here? I extended this guy all the way to 44. I don't do that for the star. I go to the next highest point. So what was the next highest after 44? 50? Was 50 the next? Yep, 50 was. So I would go to 50 instead. So I would go here. So how do you know if it's a modified box plot? If you have stars on it. If there's stars on it, then it's a modified. If it's no stars on it, then it's a regular box plot. That's the only difference. You don't put outliers on the actual box plot or the whiskers that go out. That's the only difference. Okay, because sometimes you'll see a box plot and you'll have stars on it. You're like, what the heck are those stars? Those are outliers. Okay. Okay, so I'm going to show you on the calculator. I'm going to show you on the calculator how to do this, because you're going to have to do one on your own here in a second. And I want you to use the calculator to do it. Okay, so let's get the calculator handy. Okay, after we turn it on, quick guess as to where we go. Where do you think we're going to go? So how do we get to the list? You're going to go to the list. How do we get to the list again? Not y equals stat edit. Stat edit. Okay, stat edit. Mine's loading up real quick. Yes. What's that? So yeah, so we're only going to use our list that we create right now. This is the one we're going to do it for this one here. You're going to do it on your own in a second here. So I want you to delete any lists that are already in there. unless it's already those numbers. If it's those numbers, don't delete it, but watch. Let's see here. So stat, edit. Are these the numbers? No, these are different numbers, right? So I'm going to hit up there and then clear and then down. Now I'm going to put in those numbers that we just had, those heights, 65, 72, 68, 64, so on and so forth. So there should be 24. So the last number you put in, it should say L1 parentheses 24. And then I always do a once over to make sure none of these numbers are weird looking. Like if I have any numbers that just say 7 or 5 or 6, that means I missed something. So I go once over just to take a look and I'm good. Because that's the mistake you'll make most often. Most often when you're trying to put 2-digit numbers in, you'll accidentally put just 1 digit on and it'll make everything else, it'll affect everything else, okay? So if we want to graph, where do we go if we want to graph now? If we want to see a graph, where do we go first? After we put the thing, we go, not there yet. We got to go somewhere before that. Second y equals. Second y equals stat plot. Okay. So plot 1, we only need 1 plot. It was a histogram before, but we're going to change it. Okay, so I'm going to put, make sure it's on. So now we have 6 graphs we can choose from. We've chosen the histogram already. We don't need to do that one right now. We need to do a box plot. Well, we have 2 options. Exactly. We have 2 box plots. One of them has a little, like a little trickle, and one of them doesn't. Which one? Why do you think it's a trickle? Yeah, Christian, why do you think it's the 2 dots at the end here? That one's a modified. So which one do we use? Always use modified. Always use modified. Because modified will tell you if there's an outlier. The other one won't. If there is no outlier, then you don't have to worry, then there won't be any dots, okay? So hit enter there, okay? Let's see, second y equals, and then enter. That's right. Okay, always use modified. What's that? A mark? What do you mean a mark? Oh, mark right here. That's, it's just showing you how do you want to see an outlier. If you have an outlier, do you want it to be a little square, a plus, a dot, or a smaller dot? That's all it's saying. L1 is my list. Frequency, we don't touch. Yeah, how do you want to see, if there is an outlier, how do you want to see it? Do you want to see it as a square? Do you want to see it as a plus? Do you want to see it as a dot or a smaller dot? It doesn't matter. Okay. All right. So some of your calculators, I've noticed this little bug in it. If you hit zoom right now, it'll give you like an error or something. So click out of it, go second, quit, back to the home screen. If it's your calculator, you don't need to do that. But some of our like I said, these calculators have been used by many, many students. So second and quit, because it'll give you an error. Because that's sometimes you guys the last time said, oh, I got an error. I couldn't hit zoom, right? So if it does that, just go there. Now we're going to go zoom, right? We want to see the graph now. Zoom stat, number 9. Okay, does that look familiar? It should look familiar, right? It's the picture we have drawn. It's the modified box plot that we had drawn. This is a quick way. Let's say you're on a test. Let's say you're on a test and you have a set of numbers and they want you to find the outliers. You can use the formulas or you could just graph it, and if there's a dot, there's an outlier. And then you could also just use the trace feature, trace, and then median, Q1, and then find the outlier. Okay? That's a quick way of finding outliers. There's two ways to find outliers. Use the formulas, but they don't give you the formulas on a test. I won't give you the formulas on a test. So it's kind of hard to remember. Or just use this graph on a test, and if there's any dots that show up, you got an outlier. Okay, it's kind of a trick to do that. Okay. Alrighty. One other thing. How do I get the calculator to show me what the minimum, the maximum, Q1, Q3, median? How do I get the calculator to show me all of those? You remember how to do that, Remy? Trace is one way. What's another way? Yeah, Daniel. There you go. Tell me if you know the steps. Click stat and calc. There you go. Yep. For list one. And there they are at the bottom. You scroll down the bottom, and there they are too. Okay. Yes. No, this won't show outliers. You have to use the graph to show outliers. Yeah, the only way the calculator will do outliers is if you do that graph. But remember, don't choose the wrong graph. Sometimes students will pick the this box plot over here and it'll give you a box plot, but it'll look like our first one, and it won't help you with outliers. They'll use this one here, and they'll say, oh, there was no outliers. Well, you use the wrong graph. Okay, that's why for this class, I never use this one here, because I'm always looking for outliers pretty much. Outliers are always, modified box plot is mainly what we use when you see them. Okay. All right. Okay, so now what I want you to do is there's another question down there at the notes. It's Barry Bonds home run counts. Okay. It's got A, B, and C. I want you to do that problem. I want you to do that one. Use the calculator. You can use the calculator to do these. Okay, I don't mind that. That's fine. Okay, I'll give you about 10 minutes or so to do that, and then we'll talk about it. Okay, so that's what the picture looks like. If you did a regular box plot, this whisker, we call the little lines whiskers. The whisker goes all the way out to this guy here. If you did a modified, it looks like that. The thing about doing a modified is that you kill two birds with one stone, because the next question is outliers. Are there outliers? Yeah, there is, right? Looks like on the high side, there are outliers. So you go to trace, 73. 73 is an outlier. Now you can use the equations too, but there's never going to be a time where I'm going to say you can't use a calculator. In calculus, we can't use calculator a lot. In this class, we can use our calculator for anything. So why would you not use the quicker way like this, right? Can you use this? That's fine. It works to tell outliers. Okay. The only time you can't use this is I've seen on tests they'll do this. They'll only give you the 5-number summary. They'll give you the 5-number summary. They'll say, here's the minimum, here's the maximum, here's Q1, here's Q3, here's the median. So you can build the graph, but yeah, you can't graph it without all of the numbers, right? So that's the only time when you need to know this, okay, to use that. That's the only time. If they give you all of the data, then just use the calculator, you know. Okay, 73. 73 is an outlier, okay? So we have the minimum, the maximum is 73, Q3 is 42, median is 34, 25 is a Q1, and then 16 is an outlier. Or sorry, not an outlier, the minimum. Okay. Are there any outliers? Yes. What's the value of IQR? Well, Q3 is 42. 42 minus 25. 17. Okay. Why did I choose Barry Bonds? Any Giants fans? Why did I choose Barry Bonds to have an outlier? Anybody? No one's a Giants fan? Steroids. He took steroids. This is when he took steroids. Before this, he didn't take steroids. And then he took steroids. If you tell a Giants fan that, they'll get mad. But I don't really care. 73. So that's why people say he took steroids. So that's why he hit a bunch of home runs that year. Okay. So one other thing, one last thing, we're done. One last thing, we'll finish a little early today. One last thing on your assignment. I'm gonna post the assignment tonight. It's not due till Tuesday. Okay, so you have all weekend to do it. It's not due till Tuesday evening. But one thing they're going to talk to you guys about is something called the value. What? Say it again. Means the number. What represents IQR? So Q1, Q3 minus Q1. The value. Anytime they say use the word value, it just means give me the number. So they're going to call something called a parallel box plot. What is that? It's nothing new. It's just two box plots using the same. So two box plots or more, two box plots using the same number line. Has to be the same number line. Okay? So I'll give you an example. I just want you to write that down in your notes so that, because you're going to see it on your assignment and you're going to be like, what the heck's a parallel box plot? It's kind of like a back-to-back stem plot when we talked about that, but it's with box plots. Two box plots using the same number line. Okay? I'll give you an example. I'll give you an example in a second. So if you're like, what is that? I'll give you an example in a second. Okay? I should have done it on here, but I didn't, so I'll show you. Okay, so this is what it is. Let's say I had Barry Bonds's. Let's say I had another player, Alex Rodriguez, David Ortiz, some other player, right? And I said, make a parallel box plot. So you would create one line, one number line, so label by whatever you do, I don't know, whatever you need to label by, right? You would graph one up here would be Barry Bonds's, and down here would be the other one. Okay? So you do exactly the same thing you just did, except you're graphing them kind of against each other using the same number line. Okay? That's all it is. Sometimes you'll see them like that. Sometimes they'll stack them. Sometimes they'll put one over here and then put one on top of it like this using the same number line. So it's the same. It's a way to compare. It's a way to compare. Okay? So one number line that covers both sets of data. Okay? And they'll always be the same. Like home runs, they'll both be home runs. Heights, they'll both be heights. Like if I had these heights and then I measured you guys too, and I had two sets, I had one from 5 years ago and one from this class, right? And I would do the same. I would do one number line, one's 5 years ago on top, now on the bottom. Same number, same box plot, nothing changes. It's just two box plots on one. That's all it is. Okay? All right, guys. All right. Like I said, I'm going to post that tonight. It won't be due till Tuesday. Okay? It won't be due till Tuesday. It'll be in your book. Okay? We got one more thing to talk about next week, and then we're done with chapter 1.